Hi, my name is Steve, and for today's project, I want to take you through my process for using 3D printer components along with a computer to add motion to my time-lapse videos. Right now I'm going to go through how I do that to capture time-lapse of the 3D prints that I do, but I also use this for a lot of other uses in which you want to automate camera movements and any type of motorized automation hands-free, so that as a one-person crew, I can manage the camera, I can manage the settings, and I can have things happening around me that typically would take multiple people to do. So let's take a look. So now I want to go over a lot of the electronic components that I use when trying to do the automated process of time-lapse photography. So as I mentioned, I use 3D printer components. One of those things when I say 3D printer components is the 3D printer mainboard. So in this case I'm using a Big Tree Tech mainboard. I purchased a power supply. I had to purchase a switch and plug to go into the power supply. I also have a fan. This is just a fan that I've had. You can get different sizes of them. And then what I'm going to do is 3D print something to mount this onto. So I'll take you through that lapse time of that 3D print, and we'll get something for this to get mounted onto. But some of the other parts and pieces that go with this, one is the stepper motors. So the goal here is to use the XYZ and the extruder connections on the main board to drive various stepper motors. So since depending on the main board you would have an XY, a Z, and an extruder, some have multiple extruders. So you would have at least 4 stepper motors that can be controlled through G-code by using a 3D printer mainboard. Some of the other things that I have, one is going to be this button controller. So this controls is really used for gaming. You would see this used for PC games where you're trying to map certain buttons and button presses onto your computer. So this will get connected to the computer. Along with that is really a momentary button. So this is a push button. You want to look at getting a momentary, well, I guess you could potentially want a maintain button, but the momentary is when you press and hold it, it's on. When you release it, it's off. The maintain button is when you press it once, it's on. You press it a second time, it's off. So it depends on the control you want. There are 2 types of momentary buttons. You have a momentary that is normally closed and a momentary that is normally open. This button I was using was a normally closed, and what that means is when you hook up the wires, it's a closed circuit, so it's active. That doesn't work for what I need here. I need a momentary, normally open button so that when the wires are connected, it doesn't do anything. When you press the button is when it closes the circuit and sends a signal to the computer. But this will get wired. This came with wiring. So I'm going to hook up the wires. They're going to go to this controller unit. That has a USB plug that is going to go into my computer. And when the button gets pressed, I can tell that to map that button press to some sort of an execution on the PC computer. Other things that you can do, I also have limit switches. So the nice thing again with the main board from your 3D printer is if you're going to have things moving, if you're going to have things going up and down, left and right, turning the camera, you can hook up limit switches no different than what you have on your 3D printer, that when it presses it'll stop, and you can set certain limits to prevent it from, you know, going too far in the process. So those are some of the parts and pieces to make up the electronics for driving all the automated pieces along with your stepper motors. So the next thing we're going to do is I'm going to 3D print a mount for this, and we'll just do a quick time lapse and mount this on that. I'm also going to do an overview of how to get the button set up on my 3D printer. So we'll do that next. So there we have the 3D model that I created. We're going to take all of our mainboard, power supply, switches, all of that, and get it assembled onto here. Again, just something to hold everything in place, keep the fan blowing on the main board. Didn't need a complete enclosure. Decided I was good with it just being open for myself. So another great use for a 3D printer. You'll see why we start doing more with the time-lapse animation, but I'm going to screw all this together, and we'll move on to getting the button attached to my 3D printer. So now that we have our 3D printed mount in place, I'm using the Anycubic Vyper 3D printer. I did do an overview of this printer, so I'll leave a link up above here as well as down in the description if you'd like to go and get some more information on this printer. But each 3D printer is going to be a little bit different depending on which model you have. So that's the beauty of having a 3D printer, is you can custom create a mount that is going to have the button now installed. And what's going to happen is in between each layer, the print head is going to come across and it's going to activate the button. So first thing we want to do, let's install the button. So now that you've got the button on the mount, you want this to be on the actual Z carriage. So as the print goes up on the Z axis, your button is staying with your print head, so it keeps moving at the same time. So when you attach this, you don't want it separate. You don't want it attached to the base or to the bed. You need this on the Z axis arm going up and down. And then what we'll do later in our slicer settings is in between each layer, the print head is going to move across. The nice thing with the Vyper, it has this nice little edge here. It's going to trip the switch. That is now going to take, I'm going to take my wires. We're going to connect our wires to the button. The wires will then get connected to the button controller. The button controller will then get a USB to the computer. So we're going to move on to those steps and getting a complete setup in place. So now I want to go through my next piece of equipment, which is camera sliders. A couple different ways I've gone about this over the years. At first I started out, since I own a 3D printer, I made my own camera slider. So if you think of a 3D printer, so I had extruded aluminum and I 3D printed a mount for the camera, took some V rollers, I would attach the stepper motor, I have just an example, onto the end. I could go here, I'd have this below. This slides on. And now if you think of some of the belts and some of the things that you can use with the stepper motor, that would move the camera slider. And I used that for quite a while. But after time, you know, I really wanted to step things up. And so I did purchase an actual camera slider. So with this camera slider, I did purchase the motorized slider. This is a Canova. I'll put some links in the description. There are various types of camera sliders, but a few things I was looking for. One, motorized, but I'll go through why this one and why this particular motor. I wanted the ability to do the parallax. So with this, you can turn these control knobs, and as the mount moves, it moves your camera in or out. And it does that mechanically. So I don't have to do that with stepper motors. One of the things I was looking for in a stepper motor that I just simply wasn't able to find is a lot of them all have the motors, but none of them can be controlled by a computer software. You have apps on your phone that you can connect to, but I didn't see any out there that I could actually plug into a computer. And the reason that's important, as I explained before, is I want to control the steps. I don't want it to just move one direction and back. I want to move incremental amounts when I want to. You'll see this just has a GT2 timing belt that's connected to a stepper motor. There is a controller that comes with it. So this controller, this plugs into here, and I can control the speed, where it starts and stops, does it go back and forth. One of the reasons I went with this version was knowing this ran off of a belt that I've seen on my 3D printer, that I've used on my own homemade camera sliders. I knew that I could replace this with my own stepper motor and my own belt mount. So now this is a standard stepper motor. This will then plug into my 3D printer mainboard, and now I can control this separate movements. Now that we've gone through all the parts and pieces, we're going to go to the computer software, the setup of that, along with all of these parts and pieces connected. Now I want to show you everything laid out together. I am doing this on a Mac laptop because I have a laptop to make it easier here, but this can also be done on Windows PC. Has very similar software available, so you just have to look and see what type of software will work for you. Some is free, some is purchase, so you'll have to decide what is the best options. So quick summary, 3D printer runs independently. It's going to run off the SD card. Every layer, it's going to push the button. That's going to send a signal to the computer. We're going to work on the computer as to what does that signal do, but that signal will trigger some actions that will move the stepper motor, so the slider will move and take a picture with the camera. So let's get into the software side of things. So when I first set up for a 3D printer time lapse, where I want the 3D printer to come over and push the button, you have to set up a profile and add to your G-code in order to make the print head move over to the side, press the button at each layer. So in Simplified 3D, I'm going to show you how this is done. I'm sure you can do this with other programs, but Simplified 3D is what I have, and so that's what I'm going to show you. And in your Simplified 3D profile, I've created an Anycubic Vyper camera. In the main thing that's different here is under the scripts. In the scripts, you have a starting script, so it tells what to do when the 3D print gets started, but there is also a layer change script. Now normally this is empty, but I've found some G-code, and I will post this down below in the description, but you'll need to make some adjustments depending on what 3D printer you have and the dimensions of those 3D printers. But this will now, every time there's a layer change, it's going to take absolute positioning, it's going to do a retraction of the filament, otherwise the filament starts dripping out of the nozzle while it sits there waiting. So I take the X, move that to the 244, which is where it will press the button. This is something that will change depending on the dimensions of your printer. I also move the Y, the bed, out towards the camera so it's in the same position. You can see the entire object, so you want to do both of those moves. Then there's a little bit of a move where it pulls away from the button, so it moves over to 244, pushes the button, moves to 234 to release the button. I then have a hold for how many seconds. So depending on how many moves you're making, how long it takes to take the picture, move the camera, any other actions you have going on, you'll need to adjust how many seconds it will stay in that position. Then it just does a quick move to get the printhead moving again before it starts executing the next layer. So this you need to build into each of your models when you slice it and save it to the SD card. Then on the 3D printer, it will execute that move every layer and trigger all of the actions to happen. So on the computer, I have several pieces of software that are going to be used to drive all of these components and do the automation. I am doing this on a Mac, as I mentioned, but you can do this on Windows. On here, I have a few tools. So what I'm going to show you is first is Enjoyable. Enjoyable is used for mapping what the button and the controller tell the computer to do. So when the button's pushed, what is the computer going to do with that button push? In this case, all I want it to do is to do a left mouse click. So if I click on this, it's going to highlight button 12. It's going to show me that's the button I have it attached to on the controller, and I have told it to make that a left mouse click anytime you press that button. I do have to enable it in the mappings, which it is, and so now anytime that button is pushed, it will be a left mouse click. I also have my Canon camera directly attached to the USB, so I am able to trigger a picture and take a picture from the computer. You could do this with a webcam. There's different ways of attaching cameras to the computer to control them, but that's one of the things you'd want to do. And then I have set up Simplify 3D, but I'm not using it to control the 3D printer. I'm using it to control this 3D printer main board that's controlling all of the automated stepper motors. So Simplify 3D will be driving this controller. So the way we've got this configured right now, the stepper motor on the camera slider is attached to the 3D printer main board. I'm connected through Simplify 3D. You can use other software for this. Anything that can control a 3D printer will work. So if I click the 10 millimeters, you'll see that the camera slider moves 10 millimeters. I can move it back 10 millimeters. So by pressing that, there are other options that I've done for more advanced. If I've got 3 or 4 stepper motors that I am controlling and I want them all to be synchronized together, you could write some separate G-code, create a G-code file that would tell it the XYZ extruder, how far you want each one to move, what speed, and it will synchronize all the motors to do that at the same time. The last piece is a macro recorder. So this is the part that you'll have to look at Mac, Windows, different options, but a macro recorder records your keyboard and mouse movements, your mouse clicks, saves it, and then you can play that so it will repeat those steps over and over and over. So if I think of what I'm trying to do, I want to have, when the print head comes over at each layer, presses the button, I want it on the computer to take a picture and then move the stepper however many millimeters I want it to move. In this case, I'm going to use 10 millimeters just to show it as an example, but you would want to do a calculation. If you have, if you want to move your slider 600 millimeters and you've got 100 layers, you're going to move it 6 millimeters every time, every layer, and take a picture at each one of those. It'll be a little bit choppy, so the more layers you have, the smaller the steps, the better the animation across the move. We are going to take this repeater software. I have mapped the record button to one of the buttons on my computer, but I'm going to record. I'm going to start recording. I'm going to take a picture. I'm going to move the slider 10 millimeters. I'm going to come back and stop the recording. Now when I came back, you'll notice I kept the mouse button over the play, because you want it, when it's done, to return the mouse button to the play. So when the next time the layer presses the button, the left click will click the play button on your repeater software or whatever macro recorder software, and now I can leave the room and this would just run and execute over and over. So just as an example, I'm going to press the button. You should see repeater take a picture. You should see the slider move, and then repeater will go back to the play button. And now you have a repeating process that is driven off of your 3D printer, automates the entire thing. So there you go. A one-man crew, fully automated, walk away from your 3D printer, let it print, let it do the time lapse, let it add motion, and really enhance a lot of the methods in which you can capture a lapse time video of a 3D print. This obviously can be applied to so many different things that really becomes your imagination. So I hope you enjoyed this. If you did, would really appreciate a like. If you want to check out some of the other videos that I've done, some of the other lapse time that I've done using this equipment, check out my channel. Would appreciate it if you could subscribe. Helps me grow the channel and continue to focus in on this type of content. Feel free to leave any comments. Is there anything here you would do differently? Anything you'd like more in-depth overviews of? And I'll see what I can put together. Thanks. One of the things I'm going to let you see at the very end here, I'm doing a lapse time of a time lapse of a 3D print. And this is the first time I'm using my laptop, the first time I'm using the Anycubic Vyper, and some issues came up along the way, and I thought I would just include them at the end of the video because I think it's good for you to see not everything works perfectly.